Hi there everyone, today we are going to be looking at the surface area of pyramids, cones and spheres. So first of all, here we've got some pictures here of pyramids and cones. Just a few words, the apex of the apex here, which is this bit here. Don't want to call it the pointy thing, we call it the apex. We've got the slant height, which is this bit here. So on a cone you do have a slant height, this length here. And that's really all we really need to know, the height of these things here, and we've got formulas that we know to work out the surface area of these things here. So if we look at a pyramid and do the net of a pyramid, you can see that it's made up of this base area here and then just four triangles that are all the same. Okay, so if we work out the length of the base, the slant height, we've got the area of that triangle on the side, we've got the base, we're all good. So let's do a few examples here. First one, the surface area of this square pyramid. So when it says square pyramid, we're talking about the base here is square. So you can see there's these little dashes here along the side. So these are all 8 millimeters. So the area of this one here is obviously going to be in millimeters squared. So once again, I'm going to do it all in one step. The area is going to be the area of the base. So that's just 8 times 8 plus 4 times the area of each one of these sides. So it's just a half times the base times the height of those triangles there. And that's it. And then you just grab your calculator out. So that will give you 256 millimeters squared. So let's look at a question now where we're working out the surface area of a cone. Now this is a little bit tricky and it's a different formula which you'll be given. The derivation, or how you get the formula, is right here on this page here. And it's a little bit tricky, and I'm not going to go through it all in this video, but basically if you take a cone and you split it down the side, and of course the bottom of the cone is just a circle, that's easy. But if you get a cone, you split it down and you flatten it out, you actually get something like this, which is a sector of a circle. The 2 pi r, the original radius of the base, is just this bit along here. Okay, so a little bit of information here. Don't worry too much about that. The end bit you need to get to is this. The curved surface area of a cone is pi rs, where r is the radius of the base and s is the slant height, this thing right here. Okay, so of course the full formula is pi rs, the curved surface area, and then pi r squared for the base of the cone. So the surface area of this cone here, pretty easy. It's just pi rs, all the information is given here, plus pi r squared. Always write this step out. In your working, don't just have the answer, okay? That step there will get you 2 out of 3 marks. This question might be worth 3 marks. What I've written there will be 2 out of 3 marks. So if you go on and make a mistake, you'll still get 2 out of 3. If you just write the answer alone and get it wrong, even a little bit out with the rounding, whatever, you're going to get no marks. So please write that step in there. And you should get around about 880 centimeters squared. That's rounded to the nearest centimeter squared. So lastly, the surface area of a sphere. Now this is even harder to do the derivation of. I didn't show you the last one. I'm not going to show you this one. It's even harder. You need some calculus stuff, which is pretty cool. But just kind of think of this. Imagine getting an orange, splitting the orange down the middle. So you've got a circle right there in the middle. So if you look at this sphere over here, you think about the middle, right in the middle of the sphere, the biggest bit that you've got. We'll call this the radius here. Imagine taking that out. How many times, we know the area of this thing here in the middle is pi r squared, right? How many of those do you think you could fit over the surface of this orange? So you take that middle bit out. How many do you think you could fit over those? A lot of people say 3. Some people say you could fit 5. Well, the actual answer is, if you do a little bit of working, you can fit 4 of them. Exactly 4 of those middle bits of the orange. If you sliced a really thin wedge out, how many of those could you fit all over the surface area? You can fit exactly 4. And that is the surface area of a sphere. It's 4 lots of pi r squared. So if you have a hemisphere, then the answer is half of 4 pi r squared, and then you've got the pi r squared at the top. So you've got 3 lots of pi r squared. If you've got an open hemisphere, this one here, then it's just 2 lots of pi r squared. All right, so this first question here, calculate the surface area for part A. The surface area is just 4 pi r squared, and that is 3631.7 centimeters squared, and I'll leave you to do the second one.